Hey, Chris. Happy, what did I say? Saturday. Happy Saturday, my man. Hmm. Sorry, Chris. I see your messages. I'm trying to fix something real quick. Stand by. What is going on here? I'm trying to get the server set up, and it's acting a fool. It's throwing a new error that it's never thrown before. This is very, very rude. Very rude. See if we can get this to work here. Let's get started. I don't even know if it's going to capture the right screen on here. Let's see. Hey, it did. All right. What's up, everybody? Happy Saturday. All right, let me catch up on these messages, Chris. Sorry, I was trying to get something set up here. So, great news. A cyber firm has reached out to me considering bringing me on to have to audit a client with SEO correlated to the cyber operations. So I'm innovating a custom report right now. Things work out, I might have my first cyber adjacent or proper cyber gig to get some GRC help. Nice, dude. That's cool, dude. Oh, you're still working on the plumbing problem? Oh, that sucks, man. Yeah, dear Jocko. Sponsor the stream already. I wish, man. Yeah, dude, it's weird. I'm not sure what happened here. So, let me go ahead and kill the LangGraph server here real fast. That's all. Let me test something here real quick. Let me see here. All right, I think I need to modify something in the LangGraph server SH. Let me do this. Let's see. Bring this over here. Close this up. All right, so here's what we currently have. Here we go. Let's change this host value here. 10, 5, 10, 10, because that's our dev host right now. Let me try rerunning this here. All right, so this should work. It is running on that endpoint. You're killing me, Smalls. Let me try this real fast here. I don't get why the server all of a sudden is acting a fool. All right, well, let me try this. It's going to want me to log in, isn't it? We didn't change anything. There's been nothing changed on this box. Look at this. Nothing has changed here. And yet now it's all acting funny. What the crap? Show the LangGraph server who's boss. I'm trying, man. Might see about upgrading the LangGraph API here. Let me see. I think it's update. No, that's not it. I gotta remember what the command was. Let me see if we can update the LangGraph API. Maybe this will fix it. No, nothing there. I gotta check the package lock real fast. Let's see. LangGraph API. Where did we lock this at? We locked it to 438. Let me try adjusting this. We're going to try and lock it to less than 5.0. So then from here, I think we should now be able to update it real quick. Let's see what it does. Is that ghost? Which ghost? All right, now will it actually let us run it? Let's see. You're killing me, Smalls. What is this? The server's definitely running. Hang on a second. Let me clear this. Let's do, I don't have the, do I have netstat on here? I do. Okay. Let me check this real quick. So for some reason, the dev server is not wanting to run. So we got to troubleshoot it real quick. What port is this supposed to be running on? I think it's 2024. So it's up and listening. I don't get what the deal is. Let's see. Does the API need upgrading? So it's not the actual API itself, it's just the API interface. But for some reason now, all of a sudden, it has decided that it just wants to act a fool. So, never been any other issue with it. I think this is probably a minor symptom of poetry or how PyCharm is interacting with poetry in here. I think PyCharm is changing some stuff in the background. It's pissed me off. Yeah, what is going on with this? Let's see. So we run the LangGraph dev server. We configure it. There's our studio JSON. That just tells it where to find all the various entry points to the agents. We tell it what host. We allow blocking, no browser, so it doesn't open the browser. The tunnel was failing anyway. Someone else said they had this same issue. They recommended changing it to like localhost. All right, let me try that real quick. Let me see what this says right here. If I change this to localhost, so it's referencing the 127 address. Well, actually, that won't even work because the server is actually configured to work here. I can actually change this back. I could go back. If I change this back to quad zeros, it'll listen on all interfaces. And then we can rerun it and see if it'll connect now. I don't know what this thing's doing. LangGraph, I want to love you, but then all these little weird breaking issues. All right, connect to local server. Okay, so that worked for some stupid reason when it shouldn't have worked. So this one's not working here. Allow an origin. Allow star. Will that work? Let's see. Crap, I don't know. 192.168.00/16. Will that work? Well, let me do that. I forget how you have to specify these origins. Let me think about this. What was the actual, hang on. Something else we can do here. So before we had this running through a tunnel. So what we'll do is we'll comment out that one. We'll have it run through the tunnel again. I'm going to try something here. So when we run it through the tunnel. Let me shut this down. That'll allow us actually to go through a Cloudflare tunnel. And then we might just have to add that Cloudflare origin in there. Here we go. So we need to copy this. Let's throw this in here. Then we're going to connect to local server, advanced, and then we're going to allow an origin here to be this one from Cloudflare. That's the dumbest thing ever, but okay. At least you know what's happening. So what's happening here is that was a cross-origin request. Okay, what does CORS actually stand for? Yeah, cross-origin resource sharing, CORS. So the idea is that you're restricting which domains can access certain web components. So in this case, this web interface was saying it wasn't allowed to connect over to those other systems in there. And we had to just tell it that it was manually allowed. So, oh well, at least it's working now. Let me go grab the test data. That was weird. That must have, oh, you know what the update is? The update's not on our side. The update is on this side here in the actual interface up on Langsmith. That is rude. That's very rude. Anyway, let's come over here and let's kick off. Let's come over to Stinger. Let's get our seed run going. Is that the right IP address? Hang on. 157, 140. Yes, it is. Submit. All right. Let this run so we can get started. Anyway, I hope everybody had a really fantastic Christmas. You're able to spend some time with your friends and loved ones and just had a good time. I had a very good chill out time. Played a little Alan Wake the other night on Christmas night just to come hang out in case anybody didn't have friends and family to come hang out. I wanted to be able to have that little just hangout time for everybody. And plus, it's such a fun game. The story to it is really good. And then today, I took the kiddos out to go riding on their four-wheelers, and they were having a blast. Just having a great time. One of my nephews got a little upset because he got a little lost in the trails, and a couple of the other folks that were out there, because this is a public area, found them and then guided them back to the camp, and he looked really distraught and upset. I was like, dude, it's all right, man. I told him if you get lost, all you got to do is don't stop on the track. Just pull over to the side a little bit. If you're in the grass, that's okay. Everybody out here is really cool. They're willing to help you. And if you get lost, they will guide you back over here. And that's exactly what happened. But he was still like kind of, like I said, a little upset about it that it happened. I was like, dude, it's fine. Don't worry about it, man. And then he went back out there, was having a great time. He was ripping around. And then his four-wheeler died. We're like, well, what the heck? So I go grab a tow strap, and we don't have another four-wheeler to carry it back. So I just hooked it over my shoulder and slugged it back a half a mile through some very, very sandy sand. And after we got back, then we start taking a look at it. He had split the radiator hose. So all his coolant was just gone. We're like, crap. So now we got to tear down the engine, make sure the piston didn't get fried in there. But it's just all part of the game. The kids all had a good time. Agent Zero and his cousin were just tearing it up, having a fantastic time out there. So that was good because it's supposed to get really, really freaking cold starting, I think, tomorrow. And I don't know when the next time we're going to get to go riding is. All right, should I let it run through the exploitation agent or just kill it? So actually, while this is running, I'm not actually using Claude to help write any of this code, but I've been experimenting with it more, so I had it help out with this. There is an issue that's occurring here. Here we go. So this is what I sent to Claude Code. It has access to read the code, but it's not actually writing anything to it because, like I said, I want to do this. But this was a really odd issue that's coming back. So I told it, hey, I've noticed an issue where the exploit revisor will sometimes call the language model and it's returning an empty dictionary. I told it, check the library versions for LangChain and see if there's any known issues. So I actually did that, went out, did some web searches, looked for it, and it did actually find an issue. And it has to do with the way we structured some of the data parsing in the tool calls here. So let me come back up here. So based on the analysis, it's a known issue. So the code for the exploit agent directly accesses output tool calls without checking if the list is empty. So when Anthropic decides to respond with text instead of a tool call, that should be blank. So there's two other fixes that suggest here. But actually, it should be replying with both, though. That's the kicker here. So we could force tool usage, or we could have a defensive check in here. But actually, this was its first attempt. I said, there is a tool call being returned. In this case, exploit step updates. But the tool call itself is an empty dictionary. So then it went through and it did another check, found the actual problem, and suggested some fixes. So the suggestion from Claude Code was that it was a potential schema issue. So because we're mixing a typed dictionary and a base model from Pydantic. So we're going to unmix those a bit, and I think that's going to be... I'm not going to fix it completely right now. I think what I'm going to do is I'm going to fix this instance, and I'm going to put a to-do list for when we do the overhaul to actually go through and make that kind of like a standard practice with it. So the error seems to be coming from how we're mixing up these two different tool calls. So potential fixes are, one, we can downgrade to Claude 3.5, which is not an option. We can add an explicit schema in the bind tools parameter, or we can also convert the typed dictionaries to a base model for the nested types used in the tool schema. So that might be, this is actually the path I'm thinking about going down right now. And this is, I think, how we're going to fix that issue. You have to remember here, if we go look at the graph, it probably ran into this exact same issue here. Let's go take a look. Yeah, key error updates missing. And down here, the last thing called is going to be the reviser. It's going to say, hey, yeah, cool, I called exploit step updates. Here's all the data for it. And then, blah, nothing. Just bubscope. So instead, what we need to do is we need to go build an identical copy of the exploit step and make it an exploit step schema over in output formatters. So let's take a look at this real carefully and see kind of what it does. Actually, let me look real quick here. What else did I ask it? So I told it then the exploit step and the initial access exploit are nested parts of the LangGraph state table. Can you use a pedantic model for LangGraph state table? So apparently LangGraph does support typed dictionaries and pedantic base models for the state, but there's certain caveats to it. Better solution is to keep it as a typed dictionary, but create separate pedantic models just for the tool schemas. So that's kind of what we're going to do with this here. So let's go look at that. So we have, where's the code here? Let's minimize all of this stuff. Let's see, we're done here. We're done here. I'm just going to roll this back. We're not going to do that. I don't want to emit any changes there. And then let's come over and look at our output formatters here. So here's what we've got, right? So the suggestion from Claude Code was we make an exploit step schema right here. And then the updates is going to reference this exploit step schema instead of the actual exploit step here. So this exploit step that it's referencing, it says, hey, by the way, your update should be a list of those steps. That's all the stuff that's over here in the states right here. So here is our exploit steps. So minor difference. This is based off of a typed dictionary. This one is based off of a pedantic base model. So here's what we're going to do. We're going to come in here. We're going to say, we're going to make a new class. We're going to call this our exploit step schema. And we'll make that a base model. So it'll use all the pedantic goodies in here. And we're going to duplicate this out. So I'm going to come over here. I'm going to copy this and just use it as the base format for this. Let's see, how am I going to do this now? So this is what it should be returning. This is going to be, and he said this is equal to a field in here. So I'm just going to bring this down. We'll say that's going to be a field for a pedantic field, and we're going to give it a description here. So let's see, this will be our, actually I take that back. I need to define what this is first. This is going to be an integer or a string. So that's going to be a string type, and we'll set that now equal to a field. And that's going to be our description. And here's our description right here. So we're basically just going to reformat all this code back over here. And we'll just get rid of that, just like so. So we're going to turn each of these fields from our exploit step over into a pedantic base model. That way we don't have to worry about mixing and matching the two. They can just work together in here. Should be kind of coherent. Did I not change the title? Are we still doing Alan Wake? I am a pro strummer. I am. I changed it on YouTube. I forgot to change it everywhere else. Yeah, that would explain why everything's all functified. All right. Change that. We're definitely not playing Alan Wake. Let's see. Software and game development. There we go. Let me change that. Thank you, 44. What's up, man? All right, let me go change this over here too. All right, there we go. Yeah, I screwed up the title. All right, updated. Yeah, thanks for the call out because I screwed that up bad. All right, so let's change this. So the iterations, this is going to be an integer, and then We're gonna set that equal to a field with a description value. And here's our description right here. Boom, just like that. So we're gonna just clean this up a wee bit. So this will be another string. And we'll do the same thing. So we're gonna set that to a pydantic field. And then our description here. No, that's not correct. Stop. Stop it. You stop. Description. It's going to equal this. Change that. All right. A couple more of these to clean up real fast. And we'll do the same thing here. Let's come right here. Field and our description is going to equal this long string right here. And we got to close that up. All right. Last one. We just got to clean up the step task here. So that's going to be a string. Description. And then we'll set this just like so. Okay. Shut up, baby. I know it. All right. That should be good. So now what we're going to do is rather than having this say, hey, this is going to be an exploit step, it's going to now reference exploit step schema. So the base model here is going to reference the base model here. Should be copacetic here. The initial access exploit, I don't know if we'll need to change that. If we run into the same issue, we'll do it. In fact, let me go put this in the to-dos for later. Let's see. Ooh, I don't want to do this. Also, hey, Monkey, what's up, brother? Happy Saturday. This is not the part of Alan Wake I remember. I know. 44 told me I screwed it up. All right, let's see. How do I want to do this? I'm just going to put a note here. Create pydantic base model schemas for use with tool calls. And we're just gonna say to avoid what was it? Dang it, what was it? Is it typed dictionary? Typed, yes. Typed dict mixing. We don't want to mix the dicks. The dicks. Yeah, we'll update that. Okay. Cool, got that there. Actually, had a lot of fun, Monkey, Christmas night playing Alan Wake. Actually, I was gonna stream on Christmas Eve too, but there was some kind of big outage with AWS, go freaking figure, and it took down Epic Store, the Epic Online Store, and so I couldn't log in to play my single-player game. Thanks a lot, Epic. I hate it. All I'm saying is, AWS went hard on like, oh my god, Zors, AI is gonna code everything, and it's gonna be rainbows and kittens and unicorn farts. And AWS has had more outages this year than I think in the last 5 years combined. Maybe like just in the last 6 months. Don't quote me on that. I'm pulling the numbers out of my butt. I think they're correct though. And then now you see the CEO of AWS coming out and saying, oh no, we're not going to replace junior developers. That's stupid. I was like, yeah, no kidding. Yeah, it is a rage ramp. And guys, actually, I'm using AI stuff to do other things, just not this project. This particular project I want to do, and I want to have control over. I want it to be able to do things and see what it's doing and build it myself. Occasionally, I will use it for some kind of troubleshooting. This is the same crap I would have done over in like either Grok or Anthropic. Instead of just like, well, hey, why do I even do that? I can just come in here and have it reference the code directly, and I can get more direct interactions with it. So I'm using Claude Code to help understand certain bugs that are appearing. I didn't realize mixing a typed dictionary and what was it? Mixing a typed dictionary and a pydantic base model could potentially have this issue. So that's one of the issues that come up here. But like I said, the only part of this code that was actually AI written is this browser stuff. And I don't even like it. I'm going to rip it out and completely redo it. because not completely, like this is tools that we added into this, but I'm going to go through and I'm going to clean it up because there's just so much junk in here. And it does work, but I still don't like it. And plus, I'm probably going to change it from using a React agent to using a deep agent. We'll see. But I am going to eventually rip out this browser agent. It's working right now. It's working well enough. In fact, I had to close the to-do. Forget it. Fine. I don't need that. But let's go test this out now. So this code should have hot loaded in. It didn't like that for some reason. Fields must not use names with leading underscores. Really? Really? You're killing me, Smalls. All right. Fine. Why can't a field use a name with a leading underscore? Ah, you're killing me, Smalls. All right. What do you think about this? Let me think. All right, fine. We're just going to change it to ID. So we change that to ID. Then we got to come over here and we got to change this to ID. And then there's actually another one over here in tasking we've got to change. Where's this reference? Where's exploit step referenced? We have 15 usages in here. I believe it's in this one right here. Yeah, so ID isn't going to work, so we got to change that to ID. I think that's the only places where it's technically referenced in here. I think that will be fine. Okay. So now, nope, there's other places right here where ID is used, so gotta change that too. Man, I'm gonna run this and it's gonna crap out on itself because there's gonna be places where the code's not referenced properly. Let me see, what do I have up here? That was a breakpoint, so I just remembered what to do. Here's another one, hang on. Find, okay, do I have ID referenced anywhere? Okay, nowhere else in here. I think that's all of them. So now, did it build properly? Okay, looks like it hot loaded in. Awesome.
I'm back, baby.
Hey, Gumby. What's up, man? Happy Saturday. Let's go try running this now. That is not the right window. Where is it? There it is. Now, the bummer is I actually got to rerun this from scratch because I need it to update the pickle. Wait, no, not this one. Where's exploit? Here we go. I need to rerun the exploit graph from scratch. So it'll update the pickle on disk. So what we'll do is we'll just submit this. We'll run the entire thing again. Really, we just needed it to run to the exploit revisor. But since we changed a couple of fields, what gets loaded back into memory isn't going to match up. AWS saw what Cloudflare was up to and said, hold my bear. Yeah, hold my bear. All right. So the issue comes in, for some reason, the second time it hits the step revisor. So hopefully it will run through and actually return back what it says it's going to return. All right, so far so good. It went through 2 passes of the revisor, and now it's going through. Actually, it looked like it went through multiple passes for it. We'll have to let it cook. We're gonna just see what it does here. Let's see how this goes. Yeah. Gumby, just before you came in, I accidentally forgot to change the stream title, so it said we were still playing Ala Week. Yeah, because I'm a big dum-dum. That's why I did that. I'm a smooth brain. No! Damn it. If it fails on the revisor, chances are it's because it returned that null value. So it says step updates came back. Wait. No, okay, so it didn't return the null value. Something else just went awry. So what happened? Let's go check the... Ah. I forgot to replace one of those stupid ID values. Damn it. Let's see. Tasking line 109. Oh. Yep. Yep. That will do it. That's the scratchpad repair function. I should have checked in here more. Yeah. So this just needs to be ID, and this one needs to be ID right here. There we go. Okay. So after that loads in, which looks like it did, it was a small change. So now what we should be able to do is come back over here, hopefully just rerun from here. Oh, I did change the title Monkey, and so it should be updated now. But I forgot to have it changed properly when it launched, so... I'm having reconnect issues with Streamlabs. That's weird, Gumby. I have not used Streamlabs. Is it, hold on, are you talking about using Streamlabs OBS? That is weird because Streamlabs OBS is just an overlay onto regular OBS Studio. And so it's constantly having to like reconnect over to Twitch. Is that what's happening? Come on, little special agent. You can do it. Oh, cool. I went with the webshell.phtml route. Perfect. It did update all the tasks, or all the steps. Nice. Killer. Killer. Because I'm almost out of Anthropic tokens. So maybe tonight, what I'll do is I'll go through and I'll set up OpenRouter. And we'll start working on doing a port of everything over to OpenRouter. Let's see. We'll go after it finishes going through here. It looks like it just passed the RCE check, so it should be doing the last couple of items here. Actually, I take it back. We're gonna have to go back up to the exploit agent and make sure the exit condition happens, so it comes down to this end node right here, right about meow. Dude, speaking of right about meow, so my kids have been all over the soundtrack to K-pop Demon Hunters, and now they're asking for like explicit versions. Hey, the handoff worked. Nice. They've been asking for different versions. They'll be like, Daddy, play how it's done epic version. I'm like, damn it, all right. So I'll go look that up. And now all sorts of weird versions are showing up on my suggestions.
Incoming transmission from Marano Gumby use the desktop app, and when I click go live and it starts the stream but sits there and keeps reconnect.
That is weird, Gumby. See, I used Streamlabs very, very briefly back in the day, and then promptly went over to OBS Studio. What could be causing that? So there is one other thing you can check, Gumby, which is... There's this thing here called the Twitch Inspector. And here, I'll drop the link for you in the chat here. But the Twitch Inspector will let you go through, and it gives you like a different API key and a different streaming endpoint, and you stream to it, and it tells you what's the stream quality. Do you have a good enough bit rate? Is it stable? Things like that. I would say test it with this, and then plus you have the ability to change settings and not have to worry about like going live on Twitch. So this is another tool that you could use to kind of help get started and troubleshoot that. This is awesome. It actually went all the way through to the handoff. Nice. What was the error it came back with? Oh, it's not actually an error. It should have just been good. Nice. Nice. All right, so let's see what it did here. How much did this run cost us? 30 cents. Okay, so between these two runs, it cost us about 50 cents, 48 cents and change to actually go through and do the exploitation of this very, very simple one. But let's see what happens here. So the revisor comes back. Actually, I tell you what, let's look at the input table real fast. Let's come down here and let's see what the tasks look like that it's set up. We drill down. All right, so for our steps, we have get the web shell artifact, navigate to the upload panel.
Incoming transmission from Marano Gumby. Okay, I'll have you look at my settings in Discord when you are not streaming sometime.
Yeah, man, I'll help you out with it. Especially when it comes to like making sure you got a correct target bitrate. Twitch only supports up to a certain bitrate and resolution. So we want to make sure all those settings are solid in there. This is cool though, because we see it added a new ID called bypass1 to rename the web shell from PHP to PHTML extension. Nice. Let's see. So then it re-uploads it, accesses it in the uploads directory. What else did it do? Then it should test the web shell to confirm remote code execution and come down. Excellent. So we see it rename the file. Then we see the special agent come through and navigate and do a re-upload. Awesome. And everything looks like it's good here, man. Let's go down to the last revisor node here and see what the state looks like. Imagine how much more expensive it would have been if we did not have the scratch pad being managed in LangGraph and we just tried to have the language model spit all that crap back out to us. It'd be so much. Here we go. New initial access exploit. Here's our code. So it went with the Python route. That's totally legit. That is fine. Tool call null. That is perfectly acceptable as well. I mean, one thing we could do here, right, if we come over to the code. So the code has a placeholder in here for a command, right? So what command we want to run. So the other thing we could potentially do with this is we could tell it, hey, if you have a tool, you should prefer the tool call method versus the Python code. But that's a minor optimization. I don't think it's really a big deal. But this is the kicker here. We do have an initial access exploit. I want to go through and check the exploit agent again and see how it's functioning with this. I forget what the supported bitrate is for Twitch, Gumby. It might be 8,000. I don't remember. I have it set differently though because I've got a multi-streamer set up inside of OBS Studio. So it sends the stream to Twitch and Kick and YouTube. And so I have different bit rates set for all three of them because they support different bit rates. So I don't remember what those were though. This is awesome though. Went all the way through all the steps. So the ones that are these pseudo-random alphanumeric ones, these are ones that we initially created. And you can tell which ones get inserted because they'll have some kind of meaningful ID to them. So in this case, it named this ID bypass1 here, just like that. Nice. Very nice. Very, very nice. This sparks joy. Hey, Pinak, what's up, man? Doing great tonight. The exploit agent actually, after I fixed the server, it was doing something weird. They changed something over here in the LangGraph studio where it didn't like the cross-origin headers. So we had to go make a minor tweak to it. I just didn't know that was a change, so it threw me off a little bit. But it's working now. So that's awesome. All right, I want to go double check the exploit agent because I got to remember what was the... Actually, you know what? There should be one other thing in here. If we come down to the exploit agent, and then we go down to maybe the raw. There we go. Easier to scroll down this way. Exploit agent. Validating 5 with initial access exploit for... I should probably put a note in there. This is validating task 5. Because this is task index 5. With the initial access exploit for the target. Boop. And so we see here our host. Let's see. Here's our initial access exploit. Uh-oh. That is not correct, though. That is not correct. So we're close. The initial access exploit is there. Actually, hold on. What does the exploit router look at? So this returned to exploit handoff. Hold on. I got to go double check that real quick. So where is our router function? Let me go look at that real fast. I think it's right about meow. That is not correct. Okay, so we need to double check this line. Thank you, past me, for highlight those. The validator, I think, is fine. I installed Arch Linux on my Lenovo IdeaPad and installed Hyperland. I didn't realize how much work Hyperland requires getting it set up and configured. I know, right? Actually, I like Hyperland. But my first introduction to it was with Omarchy, and everybody's like, "Oh my God, if you're using Omarchy, are you even a real Arch user?" I was like, "It's just saving me the headache of going through all the configuration steps. I can still go through and manually edit any of the settings that I want to." And so I like it. In fact, I have an old ThinkPad sitting right next to me here, and that's what it's running is Omarchy. It's gonna be my new traveling laptop. Oh yeah, not sponsored by Jocko yet. Ooh, guys, so y'all know that I have gone through and I was working on a couple of things over in Claude Code to help streamline some YouTube video production stuff, because I'm trying to make the YouTube videos a little bit more standalone and not just cut out from the live stream. There's a lot of chaos in the live stream and the editing gets super painful. So the goal is I'm taking what I had said in the live stream, I'm cutting it out, I'm transcribing it, and then I'm using the transcription to actually build a script off of that. So it was my own ideas and everything I said, but it's going to be just more to the point. A lot of the asides are going to be cut out, and I can hit more of the high-end topics for then posting it up on YouTube. As part of that, I just realized I could go through every live stream recording I've got, transcribe them, bust them over to find not sponsored by Jocko yet, extract all the timestamps, and then have it automatically go cut all those videos out. I could make the collage to send to Jocko. Oh, that'll be awesome. I just realized I could do that. That'd be great. There's a lot of curveballs it throws when some settings don't work due to incompatible libraries or something else. Yeah, that's what I mean. Arch really is. It's a well-run operating system, but you have to get really deep and want to spend a lot of time tinkering with it. And I'm not sure that I do. I have a certain amount of time, and I have a certain amount of time that I don't have, and I'm just not sure that's where I want to send it. All right, so something happened here. For some reason, let's come up here a bit. Let's go look at something here. So here's our host, our initial access exploit from the input here. So here's the trace, right? The reviser comes through and says, okay, we have an initial access exploit. I'm going to send this to the step router. The step router then routes it up to the exploitation agent. So that's what this dashed line here is. These two dashed lines are actually a single function that can return two branches. It can either branch back over to the processor if it needs to continue the loop, or send it up here to the exploitation agent. So from what we see here, that router decided, okay, cool, we're done with the exploit. We have an initial access exploit. I'm going to send it over to the exploit agent. The exploitation agent then should take it and append it over into the initial access exploit for the host. However, Doesn't look like it did. So if we look at the input here, here's our host, right? We only have one host in here, so it makes it easy to find. Let's see. Initial access exploit, 0, empty string. So we don't have anything going on in here. And if we go down to the output, we should see that in here, right? Initial access exploit, still an empty string. So we need to go double check that. Something in the exploitation agent is not properly appending the initial access exploit. So we got to get that sorted out. Let's see what's going on with that. This is right here where it should be happening. I might try Cache OS. I heard good things about the distro while still being on Arch. I have not tested out Cache OS. I'll tell you, one weird bug I did find with Omarchy is that it will not sleep the laptop if it's running a browser. So if I'm going to put it to sleep, I have to close all instances of Brave that I have running on it, because it does something weird with the GPU and it can't quite figure out the GPU power states. All right, let me look at something real quick. So on our host object here, so we do see that the host object, nope, go back, right here. I wanted to move this over. So over here in our host object, right, we have initial access exploit. It is a list of initial access exploit models in here. So that's from this library. It's right here, in fact. So here's our initial access exploit. So what this should have done here, let's see. So first thing it does is it checks if there's a task assigned to the exploit agent. So if the current status is working, the task is a working one. Actually, let's go check that real quick. What was the actual task state when we entered the agent here? Let's see. So here's number 5. Our exploit task was status validated. Okay. So if it's working, then what it's going to do is it's going to get this exploit task right here. Hold on, what did I do this for? Let me think about this. So we take out, so basically what we're doing here is we're looking for task assigned to the exploit agent. If the task is currently in a working status, then it's going to go basically pull out that exploit task array from our output, and then it's going to iterate over it. Oh, I know why. I'm an idiot. So if we look at this right here, you got to remember, this is a nested data structure in here. So the task, index number 5, is an actual exploit task up here. Hold on, was this the input or the output? This is the input. Why was that validated already? Something is rotten in the state of Denmark. Hang on. Make sure I'm looking at this correctly. Why was this validated already? Should that have been validated? So here's what we return. So we return the host up here. All that's good. So hold on, this wasn't working though when it came in. This is the input for whenever it enters the exploitation agent right here, right? So if we come up here, this is our input state. So the state can be modified. So we have 2 tracking versions, the input and the output. So if we come over here, we already know the host doesn't have the correct item. This is set to validated right here. Let me look at something real quick over here in the step revisor. Here's our exploit task updates. We validated it, that's why. Here's our validator running through it, but we didn't hit the validator. The only place we mention attaching the initial access exploit is in this section of code right here. So it had to have gone down this track. I'm just not quite sure how it got down this track. Oh, this is if it's working. Okay, thankfully I'm a little smarter than I give myself credit for. Down here's where it says if it's validated or if it's new. Yep, I'm a dummy. So I forgot. All right, so here's what happened. The thing is, I broke scope. Yes, that's what happened. So we have a nested data structure in here. Let me see if I have, do I have my drawing up? I don't think I do. I need to work on getting the iPad set back up. Hang on, stand by. We're gonna laser pointer this real quick. So here's what happens is we have our task table, right? So our task, those go to the primary agents. That's where they work on things. We have a special case of a task that is, it is a task, but underneath this in our output field, because they already had a defined structure, under this, we then have a nested structure called an exploit task. So an exploit task, and then underneath that, we have an array of exploit steps, just like this. So that's how this looks right here. So the problem is we let the validator work up here instead of working down here. So this should have been where where the revisor should happen. So it should have been working down right about meow. And instead we let it work up here in exploit task. So we kind of broke scope a little bit. It should have been working down in the steps. We let it come up. There's two ways to handle this. Let's take a look at something real quick. So from our exploit task here, the status could be new working, validated, exploitable, or non-exploitable. The task status could be validated. So here's what we need to do. We need to modify this. The exploit task, we can let the revisor interact with the exploit task, but this is actually all a part of the primary task that we don't want the exploit agent, that little sub loop interacting with. So we can let the revisor touch here, but not up here. No touchy up here. That's what we could do. All right, so I need to modify this just a wee bit. So it does work, but it doesn't work as intended. Actually, it doesn't quite work because it's not getting the initial access exploit back out to us. So let's come down right about Chmear. Let's come down to the revisor. All right, so here's our revisor, like so. So here's where we get our prompt back, and here's where we get our output from it. Okay. What isn't it like this? Yeah, just, I don't care. That's ignorable right there. In fact, actually, this is a good point because this was in here when we thought there was a data issue with this. There's not, though. So what we want to do is, let's take this out. Let's clean this up just a wee bit right here. We're going to get rid of this. And then we're going to bring this in a little bit. Bring this in a couple scope lines. Here we go. Output's going to be response. There we go. That's going to fix this. So the reason why it was saying this might be referenced before it was assigned is because this was in a try loop. We don't need that try loop anymore. That was when we were still troubleshooting everything. It looks like taking out the mixture of typed dictionaries and pydantic models and just making it pure pydantic fixed the issue. So I've got that in the to-do list for when we do the overhaul. But for right now, this should be good. So let's see. So we had two forks here. That's right. Because we only have two tools in here that it can use. So if we come back up to the revisor, it has two tools. task update or a step update. So we handle those two conditions right here. So if it comes back with a step update, yeah, so here's our step update fork right here. So if it calls a step update, we let it update all the steps. That should be fine. And then here we say if it's a task update here. Oh, we also had the option for exploit bailout, but we actually didn't need that. So the bailout, I don't think we actually kept that in, did we? I don't think so. Oh, it doesn't like that. All right, here, fine. Fine, I'll rename that. It didn't like it. Just to make the IDE happy. All right. So there's our step formatter. Let's see. So when we hit the task updates, we need to modify this a wee bit. Let me think. So here gets the initial access exploit, new status, and for this one, that's our exploit step status right here. Actually, hold on. That should be just fine. Hold on. So that should be listed as exploitable. Because that should be the status that it's updating. It should be updating this task in here, the exploit task. So let's double check I got this correct. So we go into task, we index it, and then on our exploit task, if we look at what our current exploit task is, we get that, and then we look at the status, and we set that to our new status, which is going to be right there. We manually validate the last step. That's totally fine. Yeah, this should have been in the exploit task. Hold on. Doesn't make any sense. Hang on. So the revisor here, let's take a look at the state table, because this tracking information is very important. So let's go bust down into it. So the status for this upon entry, the task itself is working. The exploit, the status is validated already. Why was the status validated right here? Oh, that's weird. This should not have been validated upon entry into the revisor. At best, it should have been validated upon exit of the revisor. This is still working. This is still validated. When did that field get changed? That's messed up. That is not copacetic. Dang it, I already finished my Jocko drink. What do we got going on here? Let's check the previous node real quick. Let's drill down here. Status is still working here for the step update. So what's it on exit here? Output, tasks. Status is still working. See that? Oh wait, hold on. I'm looking at the wrong status. It actually doesn't matter because the output status for the actual exploit task down here is still working. So this should be working. This should be working. We come down to the revisor. Let's drill down again. Click. There we go. This one's working. Okay, this one is working. This one is validated upon insertion into here. That is not right, actually. The input here, this shouldn't have been validated yet. Upon input? No, that is way wrong. This should have been validated upon exiting, not upon entry. Let's double check something, because the only place that should have changed is if exploit task update was called. So if we come back up here, look at the revisor nodes. This was a step update. This was a step update. This one was a step update as well. Again, another step update. So that's all good. That's the way it should be. This one's same thing. Another step update. Just for grins and giggles, let me come check this real quick. What does our table look like here upon entry? So this one still says the exploit task is working and that parent task is working, which is the way it should be. So here's what I'm going to do. I'm going to split the difference. I'm going to come down in the middle here, right about to here. Well, it's a little bit more than middle just because the browser agent takes up so much space. And let's check it again right here. So we'll know that if it changed, it's changed somewhere in the middle there. So we're gonna split the difference when we're troubleshooting this. The other thing, when you're troubleshooting something, you only have, okay, both those are working. You only have really it's two options. You can technically make it three options. You can start at the beginning and work forward. You can start at the back and work backwards, or you can start at the middle and work to both ends. So what we're doing here is we're kind of starting at the middle. So here, this revisor, we don't have anything. In this revisor, what do we have? I think should be looking at the output, but that's fine. Both those are still working. All right. So now if I come down here and we check the output, what do we have? Working and working. Okay. So it hasn't updated it yet. Let's come down to the next revisor. I'm going to go scroll all the way to the bottom here. Okay, so they're both working in this situation when it exits. So we come down to the next revisor node right here. What do we get? Hey, Tanis, what's up, man? Sounds like the compression problem in Silicon Valley. Dude, I really need to go make some time to watch Silicon Valley. Unfortunately, I'm probably not going to get to it till 2028 because I'm just about to finish up Eureka. And with as little TV watching time as my wife and I have, we estimate it would take us about 2 years to get through Stargate SG-1. The middle out problem is terrible. It's a pretty awkward scene. Man, I know. I've had so many of my friends tell me, you need to go watch Silicon Valley. And I've seen bits and pieces of it. Okay, so here it's validated. What the crap? And see, here's the problem. It's validated upon entry. Actually, hold on. Let me look at something real quick. So what about the output to this? So for our output tracking messages, what do we have? Checking exploit task 0, step 7. We get our AI analysis back. Let me collapse these down. For some reason, this status right here became validated. I mean, it's in the correct step. This should be when that exploit task validated. I put exploitable and non-exploitable in here. I wonder if I should have used those more. I forgot I had actually put those as valid options for the text. All right, Gubby. No problem, man. All right, so the nuclear option is we come over here and we just search for validated, and then we have to go run through those. The only thing I don't like is, so if you didn't know, this is actually a remote desktop session over to the dev server. The only thing I don't like about it is I can't use Control F in here. So I have to do it the hard way and just manually come over here and find this way. Okay, so this manually goes through and validates the last step. If the last step is validated, then it's going to send to the exploit payload crafter. This is an old note. The exploit payload crafter doesn't exist anymore. We built that into the loop, so that is an old note in here. Let's get rid of this stuff real quick. Let's clean up this step router here. So we get the current exploit task. If current working exploit task is none, then we send it to the exploit agent. Okay, that makes sense. So the current working exploit task function here, right? It checks the state table to find the current working task in there, returns a -1 if nothing is found. Actually, I take that should be wrong though. That should be it returns a none. Return none if no working task is found. Because it used to be -1. I needed to update that. To Bob, what's shaking, man? Happy Saturday. All right. So the step router seems to be doing its job just fine. Let's come back up here. Here's our revisor node. So here's our validator in here. Okay, so if we call task updates here. So here's our step updates. That is adjusting this particular field right here. If we call task updates here, what do we do here? So we set the exploit task status to the new status. That's where it's happening. That's where the validation's happening right there. That is incorrect. This status should not be there. So actually, probably what we need to do is change that because we already had it in here. Where's our status? We had a new status called exploitable in here. So, and actually, the main place that this comes apart is actually from the prompt over here. Let's see, set the status to failed. Okay. If the verify initial access exploit by sending the pwd command is validated, do not return exploit steps, instead return exploit task updates. And here's what we do. We set the initial access exploit to the valid field. And let's change this from validated to, what was that value? Exploitable. I'm just going to copy pasta this. There we go. Now it's going to break some of the routing because I think we were looking at that for it. It's definitely going to break it up in the agent. But that's okay. So now if we look at how it's flowing through here, here's what happens. So the revisor sets the exploit task, which is this stuff down here in the output, right? It should set this status, instead of validate, it should set it to exploitable. It's going to then pass it back up to the exploit agent. But to do that, it's got to pass through the router. So we need to go look at this. Actually, I don't think we need to look at the step router. No, we don't. We don't. Because the step router just looks to see if there's a current working one. We don't have a current working one because we changed it to exploitable. We're good. So it's still going to route back up to Mir. Actually, I need to check one more thing. I just realized. What we want to check is make sure that the initial access exploit... Ah, look at this. This is why. Is this our output? Yeah, this is our output field. For some reason, the initial access exploit is not being properly populated over to this. Even though we got it back. Actually, hold on. That doesn't make sense. 1 second. Let's come back down here. Yeah, for some reason, it's not being tracked right here. That's why we weren't seeing it. Excuse me. That's why we weren't seeing it get populated to the host either, right? Yeah, that's what's happening. Because if we come down and we look at the output for the host, right here, where was that? This was our verdicts. I wonder if I need to update that. I do. I've had so much extra tracking data in here that I probably need to take out. Yeah. Hey, Gumby. Welcome back, brother. But yeah, so if we look up here, still the initial access exploit is empty. It's an empty array. So we do need to fix that. So let's go clean up a little bit of our tracking, and then the exploit agent actually might be stable. It might have hit stable version. Yes. Yes. Actually, hang on 1 second, guys. I gotta get some water. I'll be right back. All right, I'm back. Ooh, guess who's back? Back again. I'm not pooping, Gumby. You're a weirdo. Actually did go to get my water, but Peaches also needed to go outside. Of course, right as I get back to the desk, she starts giving me those little puppy dog eyes. Hey, Ty, what's up, man? Happy Saturday. All right, let's see here. This tasking workflow is complete and utter garbage. Let me take this out. So first what we're going to do is we're going to shoot about doing a pre-flight check. Pre-flight check just checks to see if there is an initial access exploit. Oh, I need to clean this up. So the exploit agent needs a lot of TLC because we haven't worked on it in so long. So let's see here. So first thing we do is we check to see if the task is assigned to exploit. So let's go bust this out real quick. Because see how we reuse this one section so many times? Let me think about this. So first thing we do is we check to see if the agent is not assigned to exploit. And what did I do here? I haven't worked on this particular node. So we've been stuck down in this loop right here for a couple of months, figuring it out, massaging it, cleaning it up, restricting permissions, expanding permissions, everything. So this one node kind of got a bootstrap in the beginning just to get it down into this loop, but now I actually need to go through and clean it up some. Let's see. So for get new task, what we have here is so we tell it what agent we want to get, and then we tell it what task status right here equals new. Okay, that's what we were doing there. So if the current task was not available to that, then what we're going to do is we're going to set this here. So down here, though, we can actually kind of break this out. So this actually should already be good. We don't have to worry about if the task is actually assigned to exploit, because this is going to take care of that. So this is all kind of hanging out code from the last time. We just need to clean up. So let's take this real quick. We're going to take this part. We're going to call this our current task. And that is going to be a task object. And that's where we're going to access this from. So we're going to go for task, and we're going to index it according to whatever the current task is right here. Just like that. So we actually need to mark that for a return right here. Put that note right there. Let's see. So then after we get our current task, what we can do is we can take this, and anywhere that we're just referencing, we're just reading data, we can swap this in. So like here, we're just checking to see if that is the correct spot. Our exploit task is going to be equal to this part right here. Yeah, that part should be fine. So these are reading tasks right here. Anytime we're actually writing to the state table, though, we want to actually reference it, because then we're going to return that data back to the agent. So that's how we're going to do it. So we look at our exploit tasks in this field right here. And if we get the status and make sure it's not none and it equals validated. So in this case, we need to change this because it's not going to be validated anymore. It's now going to be exploitable. Let me change this also. Check if exploitable. There we go. Yeah, there we go. All right, so if it's marked as exploitable, then what we want to do is we'll get our target IP from the task. We already have that in the exploit task. The initial access exploit is going to be from our exploit task, the initial access exploit. Ooh, I forgot. There's one. So we're on line 83. I forgot. There's one other thing we actually need to do. That's down here. In the revisor, we're not saving that field correctly. Here's our revisor. We gotta make sure we get this correct. Why is that? Why is it doing that? Hey, Resurrect, what's up, man? Thanks for coming online. Happy Saturday. All right, actually, look, we should have been the initial access exploit code right here that we get back from the language model. It should have been stored in the state right here. See that? So this is an example of what I was talking about. When we're getting ready to prepare data to send to another node, we're going to write that to the state table. If we're just referencing stuff for reading, we can bust it out into helpers like this. We could do it any way we wanted to. This just makes it clean so we know, okay, this is kind of like a read-only variable versus a variable that we want to emit to the next node. So if we get a task update, I'm an idiot, aren't I? I think I'm a smooth brain, is what's happening here. Hang on, let me look at something real quick. So if we drill down into the task key that we return, I think I see the issue. Actually, come out here. I called it new initial access exploit. So we now have a new untracked field in this damn thing. I'm an idiot. This brain is so smooth, you could see yourself in the reflection. There we go. That was the issue. One little misnamed convention in here. My brain's fried because I've been chasing an Intel rapid storage technology driver issue with Windows 11. So, and trying to Zorin dual boot. Oof. Oof. Is that the Intel rapid storage technology? Hold on. I've messed with that before. I was trying to remember if that was... So I had a case that it just reminded me about. For some reason, when I was installing Debian onto the test box, the one that's running this dev system over here, when I set that up, I noticed a weird thing. Proxmox would install and work just fine. Debian would install, but then Grub would always crack on it and just become unusable. Found out what happened is there was a slight difference in how it was installing using, I think, LVM, Logical Volume Management. And Debian was not doing that, and for some reason, Proxmox was. That was the only difference. So then, did the Debian install using LVM, bam, everything worked. It had to do with something, how it was interacting with the RAID array on the server. So yeah, something you installed to Windows 11, you can't really uninstall it. Gotcha. Let me check this out quick.
Incoming transmission from Marano Gumby. iFixit Blaise. My effing bitrate was at 28,000 and Twitch only allows 8,000.
See, you had a typo too. It's just a typo kind of day. That's funny. All right, so new status. We set the actual exploit task as being, now it should be exploitable. So that should be fine. Okay, cool. So now we actually should get the initial access exploit back. We should be good here. So let's go down the logic chain here. So we check if the current task is assigned to exploit, then we're all good. If here's where we set that if it's working. This is all kinds of janked. What did I do? Because look at this. This is checking to see if the status of that exploit task, right? Actually, hold on. Take that back. This is the task. You gotta remember, these are nested structures. So that's this section up here, not this section. Task has its own status. exploit task has its own status down here. So this is making sure this task at the higher level is actually working. Got it. Got it.
Incoming transmission from Marano Gumby. Why the fact they only allow 8,000 is beyond me and it dumb AF.
It is a little dumb. Yeah. I don't know where they chose that number, Gumby. So. This is definitely a rate issue. I got a refurb laptop for Christmas. That's what I've been working on. Oh, gotcha. Gotcha. I was actually really surprised at how well Omarchi was running on my old ThinkPad. And one of the mistakes I made was getting a 4K monitor on that ThinkPad, because this was back when Windows 10 was pretty much all you had, and the UI scaling was complete garbage. And so everything being based on pixel size was super freaking tiny. It was a pain. Okay, so here we're checking the task. So if the current task is assigned to exploit and it's working. Okay. Cool. So if it's not working, what do we do? Okay, so let me go, let's clean this up a little bit so I can keep track of what's actually happening in here. Man, I went hard on this, didn't I? Where else do I have this used? All up here, damn. Yep, so that one needs to change. That can go away. This should be able to be swapped out also. Actually, I take that back. Yeah, this one is going to be an output one, right? We're changing it from new to working, right? So because we're going to return this value here, we want this. See how we're assigning this directly to a basically a drilled down nested copy in the state table. So we wouldn't leave this as working, because the objects in the state table are what we're going to return back. Like I said, you don't have to do it that way. This is just the convention I've come up with to make it the simplest to track inputs and outputs.
Incoming transmission from Marano Gumby. So what the fuck do you do if you stream on multiple platforms? Will you be able to raise it so those platforms can handle the stream?
That's why I don't use Streamlabs, Gumby. I use OBS Studio, because then there's another plugin you can use for OBS Studio. Let's see. What's it called? OBS Studio. I think it's RTMP everywhere? Oh no, it's multi-RTMP stream. That's it. Let's see. Multi-RTMP. I can't type. RTMP. There we go. So this is a plugin for OBS Studio where you can actually set individual bit rates according to like where you're targeting in here. So I can come through and I can say, I can either use the default encoder from something like Twitch, or I can say encode it with a higher bit rate. So that's what I do. Now, you could still stream at that same 8K to any other platform that you want to. It's not going to be terabad, but if you wanted to have that ability to boost it for the other ones, that's how you would do it. There's also standalone servers that you can do where you stream to it, and then that server handles the actual interactions with sending it out to the other systems. That plugin just kind of mashes that into OBS Studio. All right, so let's drill through this again real quick. So that's if it's set to working, which it should have been.
Incoming transmission from Marano Gumby. Okay, thanks. New streamer worries. Hee.
No, you're all good, man. There's a lot of different pieces to learn for it. I tell you what, let's rewind this a bit. Let's come down here. And before we run the revisor, since we made the changes to the revisor, hold on, let's do something real fast. Let's make sure the code hot loaded correctly. All right, looks like it's hot loading in. Perfect. All right, so since we made those changes, we can actually back this up and tell it, hey, rerun from this point right here. Let's see if it'll actually do it. Okay, good. Sometimes when it sits idle for a while, it dumps the state table out of memory, but looks like it still had it in here. So it should crash out when it gets to the exploit agent because we changed it from exploitable. No, actually it went to exploit handoff. Okay, snap. Let's see what it did here. So when we went into the revisor here, what did the task look like? Let's see. So the task shows it's working. The status now shows exploitable, which is only possible. So for some reason, the step revisor is mixing up the inputs and outputs in here. I don't know why. It just is. But it should only be exploitable after it leaves the revisor, but it's fine. Totally fine. Piggy has her squeaky lamb is going fiercely to town tonight. I just put Peaches outside. In fact, I need to go let her in because I live in a kind of wooded area. And on my security cameras, I've seen bobcats and coyotes and stuff. And she's not a big dog, right? So hang on one sec, guys. I'll be right back. I gotta let Peaches in. All right, I'm back. All right, let's see. I'm definitely not pooping, Gumby. I just had to go let Peaches in. And Peaches, being a little turd that she is, I go out there and I see her at the back door and she's just rolling in the dirt. And she just had a bath. I'm talking 2 hours ago. She just had a bath. And the only thing I could think in her little brain is she's like, no, Daddy, I don't want to smell like an oatmeal cookie. I want to stink. Because my wife got some kind of, I don't know, fancy little dog shampoo that's like made with oatmeal or something. It works really well. And she smells like an oatmeal cookie after she gets a bath. Hey, Daniel, thanks for coming online, man. Happy Saturday. Welcome, welcome. Okay, let's see what we can figure out with the exploit task here.
Incoming transmission from Moreno Gumby. Have you ate all your Christmas nuts yet?
Oh yeah, man. Those Christmas nuts, I gobbled them up real good. Gobble, 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 gobble. And actually, Sock got onto me because apparently I thought that was a family gift from my brother. No, apparently, actually, he gave it to Sock, my wife. And so she comes out, she's like, you ate all the nuts? I was like, oh, it's a family gift and you don't really like these, do you? She's like, no, that was my gift. I'm like, oh, well, I saved you from them. They weren't even that good. They were a little too salty, kind of vinegary. She was bad at me. All right, so we go through the step router.
Incoming transmission from Moreno Gumby. That is too funny.
It is hilarious. Okay, I know this is mixing it up right here. Hold on, let me come over here. I know it's mixing up the input and output states. This is not correct. Because notice how up here, from the exploit step revisor, everything we return is all in the task field, right? We don't even touch the host field, right? So going into this, And in fact, hold on, let's double check it real quick. If we come up to look at the host field in here, initial access exploit is empty. See that? There's nothing in here. And we don't touch this field, hosts. We don't even touch it. Only thing we return is task. If we come down here to exploit agent and we look at the input state. So you got to remember, this is working like a workflow. So we have a copy of the state table object coming through here. It comes into this node, it goes out of this node. So in the input, we should not see anything in there. So this is definitely a visual reporting artifact. Because see how it knows how it's got an initial access exploit now? Good that it's in there, bad that it's showing up here. It makes tracking the inputs and outputs a lot more painful. Let me try something real quick. Let me tell you what. Empty cache and hard reload. Let's see what happens here. Maybe this is just a visual bug that they've already fixed. Hold on. I want to check this real quick. Let's see. Host. No, it's not. It's definitely something in their tracking side. I'll have to send them a bug report. Because here, I know 100% for a fact there is no initial access exploit for this host when it enters this node. When it leaves the node, yes. Because we set it in that node. We'll set the initial access exploit in the exploit task down here. So right here, where is it? Wait, this is the, hold on, it needs to be down here. This is the exploit task. Here, we actually copy the initial access exploit, here. So we keep a copy of it here that was basically the final output of this whole thing as it was coming through. I need to take that step value out. It's not important anymore. But anyway. So I know for a fact this is a visual bug. It shouldn't be happening in here. Here we go. Validating number 5 with initial access exploit. Hold on. Let's go figure out where that gets referenced in here. Okay, so this is definitely the code path it went down right here. This one. Just like this. Let's make a tiny note here. Validating task number. And then this would be with initial access exploit for whatever the target IP is. And we pull that out of it. We append the initial access exploit. We should be good there. All right. So this is definitely the code path we're going down. So let's double check it real quick. So we make sure that the task is set to the exploit agent and that that task is working. If that's the case, then we pull out a copy of all the exploit tasks. If that exploit task here, we check the status. If the status is not none, we make sure it's not empty, and the exploit task status is exploitable, then we take out the target IP, we add the initial access, or we take out the initial access exploit, we then add that to the state table, and then we set the current task to validated, just like that, boom. Because tasks don't have that exploitable, non-exploitable option to it. So we look at that. Excellent. Good save attempt. I try, Ty. We've been married for 11 years. She knows all of my TTPs. And for everybody who doesn't know, that's tactics, techniques, and procedures. She knows every single one of them. All right, let's just double check this other one real quick. So, okay, so it checks to see if the task was already validated in here. So first one is the likely scenario that it's working. The task is working. Otherwise, we say, okay, is the task validated or new for some reason? And we say, if it was validated, then we need to go check the state table again. Although we never return the current task to this, do we? I don't think we ever do. Oh, actually we did. Yeah, down here. We returned the current task. Perfect. I'm sure there's other bugs in here I'm not thinking about. I'm going to put one more one more thing in here. I'm going to put another AI message in here. And that is, we're going to say, we're going to do another format string. Actually, this doesn't need to be a format string. We're just going to say passing execution to Stinger. So that's going to tell us that we're passing, it's going to pass the execution from this when it returns back up to the supervising agent. Actually, we'll just say passing to Stinger. There we go. I think that will make it work. If that's the case, actually, I think the exploitation agent is solid right now. Ooh, that makes me happy. That sparks joy. Not bugs, features. I know, right? Let me take this stuff out. I'm going to clean this up a little bit real fast. So here's what it actually does. The language model call. Everything should be good there. All right. What did I have for here? Don't need that anymore. Take that out. I'm just cleaning out some of these unused imports. That's from output formats. Did I save that? Oh, I did. All right, we don't need that anymore, so I'm going to take it out too. Get rid of that. Ah, no, go away. Go away. What did I hit? Hit like F11 or something. Let's take that out. Let's see. I'm just cleaning up the code a little bit here since it's now in a somewhat working state. These are unused imports. We're not using these. Let's see. We had a couple of to-dos in here. What are these? Actually fix this to test the initial access exploit. Update the logic for these values. Okay. Yeah, we didn't actually do a lot of work in the validator. So here we say, okay, we're testing it over here. Else to do. Really, I think all we got to do here I forgot how I did this, actually. Hang on. Let me go look at the recon agent. Because if you notice something in here, let's take a look at the state table real quick. It's been so long since I worked on it, I forgot this field was even in here. So for this particular host, let me collapse some of these down. We were actually appending a copy of the verdicts here to this. And see, yeah, we don't have one for number 5 right here. So there should have been one in here. Oh, it's because we're not validating it. That's why. Yeah, that's why. The validator, in theory, should have come through and actually handled that part. Ah! Stupid computer. It jumped Windows on me. I apologize. Yeah, I'm pretty sure I did that in the validator nodes for the recon. Let me go look at that real quick. Where's our agents? Let me go look at recon real quick. Let me see. Edit, find, verdict. Here we go. So here's where we actually pass it with the validator prompt. The validator prompt is up here. We have that actually go with our task answer. Okay. I think we actually probably might need to redo this a little bit in here. And that is, let's go take a look at something real fast. So if we come back over here, right? How does this actually exit right here? It exits back to the exploit agent. should this actually return down to the exploit validator? Well, actually, we've already got this loop handling that. So we don't actually need the validator except for that task answering function, which is what allows us to track all the information about it. Damn it. All right. We're just cleaning up some logistics here for future tracking purposes. But mechanically it all works. We just got to basically fix the logging for it. This came to my attention, thought you might have something to say about it. Rust has been added to the Linux kernel as a programming language to improve memory safety and reduce bugs. So with its support officially promoted to a core part of the kernel as of December 2025, this allows developers to write kernel drivers in Rust alongside the traditional C and assembly languages. I mean, that's been coming down the pipe probably for a while because that's what they've been doing with Android. The Android kernel has been having Rust put into it. I think the only real issue that's going to happen with that is you're just not going to see memory safety bugs. You're still going to see logical bugs. So which usually are going to come down to like race conditions. And we've already seen that with Rust before. Rust only fixes memory safety issues. And even then, there's actually some weird things that can happen where you can break Rust if it's receiving data from somewhere else. So I'm not real familiar with how that is actually going to play out just because I'm not super familiar with Rust. But you're still going to see things like time of check, time of use, and race condition issues come up with it. So anybody thinks it's a magic bullet, it's not. But it is going to add that defense in depth for security that you want. All right, let's see here. How do I want to handle this validator? Rust had its first CVE recently as well because they had to use the unsafe flag. Rip. Ripperoni. Let me think about something in this. All right, I'm going to break out of this. Let me go over to the recon graph and refresh myself because it's been so long since I looked at it. Damn it, did I break the server? No. Should be working. There it goes. All right. Yeah, so we had the validator after this loop was all done. Right, this is a very simplified version of what's happening over in the, what is that? Over in the exploit, I'm trying to remember. Oh, in the exploit task. And so in that exploit development loop, this is basically just that small subsection of it. How do I want to handle this?
Incoming transmission from Moreno Gumby. Let's start over and code the bot in COBOL.
You're fired, Gumby. I saw a meme the other day, actually, speaking of COBOL, and it was the one where they're getting ready to throw the One Ring into Mount Doom, and he's like, "Get rid of it, cast it into the fire," and it's COBOL is the ring, and I forget the guy's name, the human who doesn't throw the ring in, and it's like banks and financial institutions. He's like, no. So actually, if you were looking for something to study to have a guaranteed job somewhere, COBOL might actually be it. I don't know how much Pascal's still used, Ty. but I hear it's frequent. I just don't know the details of it. I just know that a lot of old systems that have been working forever and they don't want to touch it, and they don't want to mess with it, run on Pascal. I'm sorry, run on COBOL. Yeah, I think the better option here is pass this up to the validator right here. Yeah, so actually, I think what we're going to do is this. We're going to add in an additional option to the router here. So this function, like I said, there's a hidden function that happens right here where it's a routing function. It looks at the state table. What we'll do is we will leave this branch in here, but when it comes back as exploitable, we're going to then send it up to the exploit validator. Yeah, I think that's the better option. And so the exploit validator is just going to, let's go take a look at it real quick. So here's the validator node real fast here. So first thing it does is it goes to the task and sets it as true. Yeah, so again, we had a separation of duties violation here, because I believe up here, wait, this is recon. Hold on, let me close this. I shouldn't have closed that, actually. I need that. Because I need to basically use this as my walkthrough. So I remember it. So basically I followed the same kind of procedure that we did previously. I remember an old friend back in 2001 starting COBOL was a great way to always have job security. Are you still in touch with him, Monkey? I'm curious if he's still got a job 24 years later. That's pretty decent job security. Yeah, so this is really dumb logic here, because all it's doing is checking if the length of the initial access exploit array is 0, and it's checking it against the host in here. So we'd have to add another condition for this. So if it's 0, then it wants to come like immediately over to this. We need to add one more check into this. Ooh, let me think about this. How do I want to do this? Haven't had a chance to connect with him for a while, so it's funny because back then I didn't even know what COBOL was. I mean, I'm familiar with what it is. I don't know any of the details about COBOL. That's even before my time, really. 24 years went by so fast. Bro, I know. There was a thing up on Twitter earlier today. Hang on. Yeah, here it is. So you get yourself 1 point for each thing that you have never done. I have used a rotary phone. I've used floppy disk. I've used a typewriter. I've taken and I did that mostly for nostalgia because I had a friend who had one, and he didn't want it anymore, so I got it and I played with it. Taken photos with an actual film camera. Listen to music on a CD or a cassette tape or a vinyl record. I've done all that. Listen to music on a Walkman or a boombox. Done those. You have VHS tapes. My first internet connectivity was via dial-up. I used phone books. I've sent postcards. I have used paper maps. When I had my first company, I used paper maps to know like where to go deliver stuff. I owned a dictionary. I owned an encyclopedia. And I still use paper checks sometimes. I got a big freaking goose egg on this. Hey, Max, what's up, man? Happy Saturday. I got 1 point for the postcard. I mean, I came back with a big old 0 on it because I've done all these things. The postcard really was just for fun, and same thing with the typewriter. Everything else, spot on. I've done those things in the past. Oh, let me think. How do I want to handle this? All right, so this automatically sets the task. So this level up here, so the top level entity, it sets that to true because this is the pre-flight check. We want to make sure that it gets true. And we're going to set this right here. I think I want to modify this a little bit. So we're going to check if the host has an initial access exploit. So if that equals 0, no exploit for the host. So then we're going to do something different here. So let's check the state table, actually. Let's get our current exploit task in here. So we're going to call this our current EX task, and we'll make that an exploit task. And that's going to come from our state table in the task field. Index that on from the state table. So from state, we'll get the current task, just like so. And then actually, hold on. I have an easier way to do this. We can do that. Let's see. We'll just call this exploit task index. Because we already have a helper function for this. This will be an integer, and that's going to be from our get current exploit task. Is that the right one? Let me see. Yeah, this is the correct one. So we'll pass in the state table there. That gives us our exploit task index. And then after we do this, we go to the current task. We go drill into the output field, and then we index that on our exploit task index. All right, cool. We're just effed on points because I've done all of them as well. I did a good 2/3 of those. I know, right? There were 20 things on there, so that gives you about a 7 or an 8 there, Max. It was funny. My wife was like, also, I think she's like, only thing I didn't do is listen to a boombox. So she was at a 1 point. All right, let's see here. I'm just going to mostly ignore this code down here, and we're just going to use it for reference, and we're going to rewrite this up here. So let's do this real quick. Let's say, first thing we're going to do is we're going to check for host IAE. And we're going to rename this. This is going to be our host initial access exploit. Actually, hang on. Let me undo that. What did I do? There we go. So that's our host initial access exploit here. And then what we're gonna do is we're gonna say our ex task IAE. So that right here, let's type that as an initial access exploit. That's what it should be. It should be initial access exploit. And this is going to be from our ex task, and that'll be the initial access exploit field. There we go. So we can then check each of these now. So we've got two different versions here. So we get the host initial access exploit, basically meaning do we already have an exploit to that target, or do we have another one in there? The idea here was to reduce exploitability. So if we already had an exploitable task in here, we wouldn't want to go try and re-exploit the host. But we actually built it in such a way that we could have multiple exploits on the host. So actually, I don't know if I necessarily care if there is a host initial access exploit. Does that make sense? My thinking was there could be multiple exploits onto the system, and we even built the initial access exploit code here. Let's see, where is it? There it is. So we even built this to where it's going to be an array in there. So we could have multiple ones. They could tell us maybe we do a different exploit. One's running as TripDub's data, another one's running as root. Maybe there's a remote root exploit. So we would want to have additional exploits in there. So I don't think I actually care if there is an initial host exploit, because we've got it set up in such a way that we are going to go check, do we have exploitability in there? Do we have multiple exploits? So we need to find a way to target this particular one. So we're actually going to take this out. I'm just going to, actually, hold on. This part right here, I'm going to take out. We don't care about the host initial access exploit. We're going to look at just the tasks right here. In theory, we could build in logic later that says, hey, we don't want to go re-exploit the target if we already have something for it, unless we have a good reason. Oh, this exploit's going to give us root access. This one over here is going to give us low priv user access. Yeah, I think that's the better way to approach it. Eventually, I'll go through and formalize all these trains of thought here. I was missing typewriter, vinyl. Oh, hold on. Yeah, I'll bring it back up. So the last couple on here were like, have you ever sent a postcard, used a paper map, owned a dictionary or an encyclopedia? The spelling on this is kind of funny. I used to print out MapQuest all the time just to have regular car atlas. Yeah, and that's exactly what I did. Is when I had when I was teaching martial arts, I would go and I would drop off flyers to all these elementary schools. So I'd sit there, I'd go pull up a list of all the elementary schools and their addresses. I'd pull up MapQuest, or I'd have the book for it, and I would immediately just copy out from a Xerox machine the individual map sections that I needed. So I went and I planned out the route, and I was like, okay, I'm going to this school, then this school, then this school to drop off flyers. And a lot of times that would be like a full day's driving. So I'd burn through like an entire tank of gas doing that. It was a lot. Because I taught in 3 or 4 different cities, and yeah, I'd have to go through that. I got 3 points because I never used a typewriter, vinyl, or a Walkman. Yeah. And what's funny is I actually just bought a record player, Max. I say I did. Sock bought it because she loves half-price books, and they have tons of old records at half-price books. So she is now going to start her vinyl collection. move this up and take that out, just like that. So we don't need these two because we don't care about that. Oh, Monkey, physical media is definitely coming back into vogue. And Gen Z is absolutely obsessed with 90s media technology because they're tired of you will own nothing and be happy as well. Yeah. Let me see. Let me put this explicitly here. So we're going to check for the exploit task. Initial access exploit. Just like that. So we're going to check for that. So we already have this right here. So what we're going to do, we're going to say if the length of that. Actually, I take that back. Hold on. Let me look at the exploit task. Actually, yeah, it's there. It's an annotated, it's not a list of an initial access exploit. So, oh, what do we initialize that as? I gotta remember. I think that's in tasking. Hang on, let me look in tasking real quick. No, that's not the correct. I don't. Actually, it might be in tasking. Format tool output. Prepare scratch pad. I don't think if we're using the format tool outputs even being used in here anymore. Here's our exploit steps. Exploit suggestions. Where did I put that? Hang on. Let me mark this line real quick. Because when we initialize the exploit task, that has to happen up in the exploit agent, if I remember correctly. So here's our language model call, exploit suggestions. That gives us a list exploitation methods that could potentially be used on the target. Where did I put this? I'm trying to remember where the exploit task actually gets generated. Hang on, let's go look at this real quick. We can actually find this in the trace down here. So when we ran this one, we started from load pickle in exploit agent, like when we first enter this. So our output is still blank, so it's not happening in the exploitation agent. Actually, it could be happening here. Let's see. Scroll down. All right. Okay, so here, so it is in the exploitation agent. That's where we're actually creating this in here. Crap. So the question is, where in the spaghetti code is it? Let's see. Here we go. This is where we actually create the exploit task. Expand the exploit suggestion. Here we go. So our initial access exploit. Oh, we did take out verdict on here, didn't we? Let's clean that up too. Let's see. So verdict and current step we don't need. That's why those were still hanging out in there. Initial access exploit is... Yeah, there it is. Initial access exploit. Okay, so that's where this is happening. It's just a blank string right now. I don't really blame people because rental culture needs to be canceled. It absolutely does. I'm so sick of it. Now they're starting to put that crap in cars. I was legit looking up like a 2001 Chevy Tahoe earlier today on, I think it was Auto Trader, because I'm so sick of it. I was like, I just want something that is old and bulletproof. Oh yeah, there was that big Spotify leak. So evidently, 300 terabytes of their live music is now is now live on a torrent. Yeah, it is. Couldn't have happened to nicer folks. The only thing I wish about that, Max, was that my NAS was a little bigger. Actually, I take that back because there's a lot of crap music on Spotify. So, like I mentioned earlier, my kids are all into the K-pop Demon Hunters soundtrack right now. And so now they want to expand to like all the remixes people have made. And they know I have listened to like a song and then listened to like the epic version of the song, right? Where it's a lot more like cinematic and it's deep bass and everything. So they're like, Daddy, can we listen to how it's done epic version? I'm like, crap. And so there's a bunch of them. I actually found one that was pretty decent. But then, because I didn't pick a next song, it auto-picked one. And it comes up with this group. What was it called? Hang on. My phone. And of course I had to make Sock listen to this because if I had to suffer through it, so should she should also have to listen to it. Bongo Cat, that's it. Hold on. Bongo Cat. This is a group that apparently all they do is they go make covers of songs and it's just cats meowing. That's it. It's just like there's no vocals. It's just cats meowing. And so I was about to change it and the kids are like, no, we want to listen to it. And I was like, don't even dare ask your mother to play this for you because she will absolutely forbid it. You're lucky I'm a softie. I'll let you listen to this weird music on here. But look at this. It's had 3.6 million plays. Oh man, there's a niche for everything on the internet. Cracks me up. I was like, oh my god. So of course I turned it on. Yeah, the second one had 14 million. That was crazy. I don't even recognize that song. It's called APT. And that's for me, APT means something wildly different. But yeah, so I made Sock listen to it, and the face. Oh my! I wish I had a picture of it. The sheer cringe-inducing pain on her face as she realized what was happening, and then it wasn't just like she went from nothing to cringe face. No, the realization washed over her, and you saw her face morph to this. It was freaking hilarious. I wish I had been recording it. It is absolutely priceless. Yes. Let me see if I can do something here. Can I take that to a none? Okay, that seems to work. So what we'll do is we'll set this to none in the beginning. There we go. So this is going to be a noon now. Okay, so if that becomes a none, let's take a look at it here. So let me come back down to here. Okay, here's our validator. So what we'll do is we're going to check the exploit task initial access exploit. So if this is none, then what we'll do is we're going to return this message. So we're going to take this, we're going to drop it right here. Okay, then we're going to do an elif statement here. Well, it can only be two values. It could be none. We're going to make it explicit, though. We're going to say how do I want to do this? What do you think? So now what the validator is supposed to do is the validator should actually validate this guy right here. So what we'll do is we'll say, actually, I think we'll just make this an else statement for now. So we say otherwise, what we're going to do is we're going to set the task to be validated. Right here. We're going to say what the question is. Now, why is it throwing an error for validated right here? Oh, that's why. Because it's dumb, and it doesn't realize that validated actually is a valid type. Look, it's like, we expected a literal. You're fine. You're fine. It's okay. This is fine. All right, here we just had a placeholder where we'll say that basically I'm going to copy this data right here. So let me copy this. Let's bring it up into our new logic real quick. And then what we'll do is we're just going to copy this guy right here. Oops. Add extra inches in there. Okay, so question and answer, we need to get those out here. Question I think we already have though. Yeah. Actually, I think what we'll do for the answer is we'll put in answer, I believe, is actually just supposed to be a string. Let me double check that real quick. Where is our task answer here? Yeah, it's just string, string, string. So the question, answer, reason. So what do we do for the question? We got the question up here. Answer. What could we use for this? Where's the initial access exploit? Let me see. We could just make this a format string. We could actually just access this all from the initial access exploit. We could say exploit present. We could say if it's code or tool. Do I want to go that far with it? We'll just say initial present for I don't want to track this. Let me think. Oh, let me double check this structure here. So the initial access exploit exists on the exploit task right here. That's what we're checking, because this is validating the exploit task. If that validates, or if it's marked as exploitable, then we'll come up to the task up here. Let me think. So I don't want to tell it. Actually, let's just do this. We'll say answer. We'll say task. We'll put in the number here. And then what we'll do is we'll put in, what do I want to mark this as? We'll do from the initial access exploit. We'll get the status from it. That's what we'll do. From the exploit task. Status. So that'll be our EX task. Let's see, yeah. Wrap that up. There we go. So we'll get the exploit task status, and then what else do we want to do here? Let's see. Let me do one more thing here. So let's do current task index. That will be an integer. I'm going to set it equal to this. So if you're wondering again why I did... Actually, that is incorrect. This should be this value right here. Just like that. There we go. So we can do this, right? We can put this in here. And the reason is because this is still going to write it to the state table. This is going to be mostly like a read-only variable in here. One that's not going to change. So then we can actually reference it down here. So we're going to say task number blank, so task 5 in this case, marked as exploitable is what it should come back as. I think that would be good right there. Hey, Yule! What is it? Yule? Yule? Hey, man, welcome in. Happy Saturday. Let's see. Actually, that should really be the reason here, now that I think about it. So the reason, we'll say it's marked as exploitable. Answer, what do I want to do for this? Actually, we'll do this real quick. We'll build this up as an individual string. We'll say... We'll say there's an initial access exploit for... I gotta make this a format string. Let's do that. Format string. This would be for our exploit task, and from that we'll get the target. Wait, the exploit task does have a target, right? Oh, it's target IP. My bad. So target IP. Because that's how we're keying all this stuff on here, is by target IP address. Let's see. And what we'll do is we'll say with, put another thing in here. What do I say? I want to say like with code or with task in here. Yeah, I think that'll be fine. We'll just leave it like that. So we'll say the initial access exploit. Oh, damn it, I really do want to do that. Because we have two options here. The initial access exploit can either be a tool call or it can be code in here. So what did it come back as? Hold on. Let me double check the state table real fast. So once we got down to this part, what did we actually get back from this? Let's go take a look. So here's our task. Task number 5. Here's our initial access exploit. Tool call is no. Okay. Actually, yeah, we could do that. Yeah, we can actually do that. We can return from this. We'll say... What do I want to say here? We'll say code if ex task. And then we'll get the... What is it? Initial access exploit? Yeah. Actually, I don't want to do this with a get. come to think of it. What I want to do here is we're going to make it a little bit more explicit, like what we're drilling into. So we'll do bracket notation here. And then we'll say we'll check the type of this. There we go. So if the exploit task type is, I think it's exploit code, that's what we need. Is that how you would do that? On? Or does that need to be wrapped? I think that might need to be wrapped in here. I forgot how to do that in Python. Python check if variable is of type. Remember how to do that. I know you could do type equals. I know there's a better way to do that. Is instance, so that's what I was thinking of. Yeah, if it's instance. That's what I was looking for. Not type. So let's take this back out. So what we'll do is we'll say that is a type of exploit code, like this. There we go. So code if is exploit code. I haven't imported that. So we'll import that real quick, and then otherwise, I think it's just a semicolon in here. No, that's not it. Is that the correct function? Damn it, I can't remember. I think that's the correct syntax in here. Hey, why is it throwing a fit about this? I love this. Hey, we expected a task answer or none, and we got a task answer instead. Hate this. Don't inspect it. It's fine. God, you're stupid. All right, so let's run through this again. So what we do is we check, did the exploit task have a none type for the initial access exploit? If so, we say, hey, there's none here. I'm going to pass it back to the exploit agent. Otherwise, we're going to come back here. We're going to say this. So if it does have one present, it's going to bust out all these variables, and then it's going to be good. So then we need one more thing, which is we need to have a proper return statement in here. Yeah, I know. I'm still working on it. I think this one might work here. That even says recon validator. God, I'm an idiot. That should be the exploit validator. And then this right here would be our question, because we're not actually asking the language model for this. We've already validated it in other means. So the validator in here is mostly just a paper pusher as this comes through. There we go. You know, I just realized this doesn't return the task back for this. So how's it updating that to true? Let me kill the rest of this code. I don't think I need it anymore. Let's just get rid of that. Clean it up a little bit. So we come through here, we get the exploit task initial access exploit. Oh, is this going to actually work? I don't know. Get rid of those two. Don't need them. God, it's been so long since I had to work in the other parts of this workflow. I'm trying to remember. Oh, the exploit agent is so overloaded. All right, we've got to clean this up a bit. Let's see. I actually kind of want to just strip the crap out of this and get rid of it and then go check it. Actually, come to think of it, what happens next is there's handoff. Here's our exploit router right here. It does the pre-flight check against it. That's how it's happening. So if we look at this, right? So here's what happens. We load up the state table from disk. It comes down to the exploit agent. When it hits it, it comes up here and actually crafts because it sees it sees the task is going to be marked as new when it first comes in here. So when it first comes in, it's going to go create the exploit task nested under the parent task. And then when it hits the router, it's going to actually pass it over to the exploit validator over here. God, there's so much junk in here. Yeah, a lot of this needs to probably go away. The validator actually should be the one updating the host in there. Yeah, that's what we need to do. It's like if we use the recon agent as a reminder, right? We come through. Now, in this case, the recon agent is coming through and now go away. Is taking all this stuff and actually putting it in the correct spot and everything. And I bet this one says, we expected a literal. Thanks. Thanks, I hate it. There we go. Clean that up a little bit. Let me see. Yeah, so here it actually updates this task here. This just updates the task, though. We have host data coming in, too. Okay, so here's our state verdicts. We append this, state host. But how's this even actually tracking? Because we don't... I'm so confused right now. Because we actually don't... So this is the return data, right? This is what we're returning back. We're returning messages and tasks. We're appending the response back, which is our task answer. I mean, that's all good. That's copacetic. And is returning it to the target, what we're tracking in the host table in verdicts. But we don't actually emit that back. So there's our state host. We're getting our target IP. That's our target host. So here again, we're working with host data. But how's this actually getting appended onto it if we don't return that back? Hang on, let me go look at something real quick. Let's look at the seed run from this from the beginning of the stream here. I don't get why these are saying like, hey, they errored out, because they didn't. So here's our recon agent, right? So the recon agent comes through and says, here's all of our data, right? Scan the target to figure out how many ports are open. So it returns a tool call, say, hey, we're going to do an in-map scan against it. In-map scan comes back, and then the output formatter cleans it up. And then in our host update here, right, well, we return this stuff back. We return the host data. That gets thrown back into the state table. And then we hit the validator right here. So this is all in the input side. Let's go down to the output side. Yeah, only thing we return is tasks. That's wild. Hold on. So we know there's a visual bug in here where hosts will automatically show verdicts as they come through, right? How the hell is that working? This is not, I think, expected or intended behavior. Because look at this. I completely forgot in the recon agent, the very first one we built, I completely forgot to emit this back. This does not spark joy. And the reason is because, in theory, the whole time I've been operating off the assumption that, hey, when this validator node gets called, it gets a copy, its own copy to work with of the state table. And any changes are lost unless we return them here. Oh, this is less than bueno. Suboptimal. Unintended consequences. Ooh. I mean, essentially what we have right now is hard proof that what we return doesn't amount for much. Here, see that? Because that's the only place that is referenced and it's never returned. I forgot to return that. But yet here we are, and it's still carrying that forward as this new piece of information comes through. That is wild. Ooh, that is highly, highly suboptimal. Because what this means is we don't have as fine-grained control over what's coming in and what's going out of the state table. Because the whole time, I've been building this under the assumption that, hey, we have a new function here, right? We have a new function. We've got the state table coming into it, right? So we have a fresh copy of it. We do some kind of process, and then we return some subset of the state table to it. So, for example, we might have some messages. We might have some tasks that we've updated, right? Boop, 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 boop. With all these various pieces. And then this actually gets emitted back down into the state table for the next node. But we've got concrete evidence that is not what's happening. If we make a change to the state table in here, it could completely bypass this loop and go straight to the next node. Oh, that is sub-freaking optimal. I think the only saving grace has been that while we've been doing this, we've been treating the state table as more or less read only, right? So we're defining variables in here, right? So we might have some variable, and this is basically a sub piece of the state table. So some little itty bitty chunk of it. And then we're working with that variable. And then we're only assigning things to the state table when we're getting ready to return it. That cannot be intended behavior. Now, granted, we're also working on an older copy. We're several versions behind in LangGraph. So all this stuff is not part of the LangChain portion of the code. It's part of the LangGraph portion of the code and how it handles the workflows and how it handles the state management. Surely I'm not the... I cannot be the first person to have noticed this. Hold on. State changes. So in this, according to this, at least it says, state changes that are not explicitly returned from a node function are not persistent. But we have proof that it is. Right here. This code, we never return hosts out of this. Let's run through it real quick. So if we look at all the return statements, in fact, an easier one would be, let's look at return here. So we look at all the return statements, right? No host. No host. No host. Here we return host from the recon agent, right? We return it here. Let's see, that's our router. Here we return hosts from the output formatter. But the validator here is what gives it away. Because we write to the host section here. We append a response. The response is the answer to our question, right? Oh, this is wild. So the response, let's track this. So we have our language model object that's kind of shared around the entire code base. We then will build special instances of it where we bind certain pieces of data we want to get back. So in this case, it's a task answer. A task answer over here has a question, an answer, and a reason for how that task was handled at the top level, right? So we get this back. We check the response, or we invoke it, we save it to the response. We see, did it have an answer? We've told it explicitly, leave the answer blank if it doesn't work. And if it's not blank, then we come through and we change that status to validated. We put the verdict as that response. So like, for example, if we come look at the state table, you're killing me, Smalls. It disconnected on me. If we come look at this, actually, it's probably because the code's broken. It just didn't hotfix in. But look at this. We have verdicts showing up in the state table. And in fact, if we come back down to the recon agent, after we already showed the recon agent, actually the recon agent does. Let's do this. Let's come down to... Actually, that's fine. Validator does not ever emit that data back, right? But if we come down in here, in our host, we see a verdict. Question, scan the target, how many ports are open? Reason, based on this data, we see this. Answer 2.
Incoming transmission from Moreno Gumby. Check time on the box.
Oh, the timer went off a long time ago and I totally forgot it. The box is closed down, which is fine because we haven't needed it for the second part for this debugging section. Oh, this is not bueno. So the recon and the enumeration agents are essentially duplicates of each other. They're practically mirror images. I can't show you right now because I busted the code, but if you look at it, they're the exact same flow. They're basically customized instances of the same piece. That's one of the abstractions I was going to do when we come through and rework this, where each of those would basically, it would have like a standardized format. We'd instantiate it, and that would be it. So we'd go through, we'd set it up, it would be copacetic. However, this has really, really thrown me for a loop right here. This part. Well, we're almost at the end of the stream. Hang on. Let me go see. Since I do have the instance of Claude Code up. This change seems to have fixed the issue. Please look at the recon agent.py and see if recon validator returns updates to the state table's host field. So I'm going to let it churn through this for just a second, because what I suspect is happening here, it's going to come back and say, no, it doesn't. And then I'm going to follow up with another question to it. I do love the little like messages from Claude Code. It's like, hey, we're manifesting. Since host is not in the returned dictionary, LangGraph won't persist the change to the state table. So I'm going to ask it now. I'm tracking in telemetry that the change to the host field is indeed persisting. Is this a known issue? Somebody has to have run into this before. I like how it comes up with these search terms, because I wouldn't have thought to like question it, structure it like this. Let's see what it comes back with. Maybe this is already a known issue because we're on a older version of LangGraph, and this was fixed later. This is known but discouraged behavior. So what's happening? This is exactly what I thought. The state dictionary is passed by reference. So when you mutate nested objects here, you're modifying the actual object in memory. The change persists even without returning it. No. No. Bad. So the state and history checkpointing won't capture these changes properly. Race conditions can cause corruption and parallel node executions. Yeah, I know. Oh, why would you do this, LangGraph? So if you're not familiar with how a pass-by reference works, you basically have two different options whenever you're passing code, or you're passing in variables to code. So they look like this. So let's say you've got a function here. So your function takes in one variable. We'll call the variable A right here. So the question is, how are you going to pass this variable in? And then it's going to do, I don't know, let's just say like A++, and then it's going to return A here, right? So we'll say return A. Very simple function, right? So if you have two options here. Whenever you pass that variable over to the function, you can pass by value, in which case it actually makes a duplicate of it and then a duplicate copy, and then it passes that into the variable. You also have pass by reference. So this is a copy of it, of the actual data that you're sending to it. Passed by reference is a memory address. And that memory address is to the actual object itself. So when LangGraph is doing this, it's actually passing by reference. So what happens? It passes to the memory address points down to the state table, and then when we make changes to it, those changes can then persist out to the other nodes in there. Just like that. That is freaking terabad. Okay. So far, everything Gumby is actually working according to plan. And I think, like I said, the only saving grace is because of how we've been handling the basically parsing out the parts we need to read and then only modifying the state table for stuff we need to return. That was a very lucky guess for this. So if we wanted to do something like this, what we'd have to do is actually break our convention. The convention works, but it is not optimal and it busts up the tracking horribly. That's why some of the stuff was looking like, hey, it's coming in on the input now. So what we'd have to do is make a local copy of this host field, modify that, and then when we return host, instead of like task up here, what we do is we'd bust it out into its own variable. And then we'd specify that as the return value. That's how it would work. Oh, that's so stupid. That is hella dumb. Let's see. All right, overall update. Let's put a new one in here in the to-do list real fast. So, new one here. Change handling of state table. State is passed by reference. We'll need placeholders for returned values. And not at the state table. The state object directly. Oh, that is freaking terabad, LangGraph. Why would you do this? Why you do this? Oh, man. Okay. Unfortunately, that's where we're going to wrap it up for tonight. So, oh, that is so horrible. Like I said, this code got lucky because of just because of a simple convention so I could keep track of what were the inputs and outputs. Got very, very lucky with it. However, this is so bad. This is so bad. In fact, hang on. I'm gonna put notes in here.
Incoming transmission from Marano Gumby. Don't forget to push it real good.
Oh, I'm going to. Damn. Oh, this does not spark joy. Let me check something real quick, actually, before we wrap up. It looks like everything should be up and running. Why would it... Oh, there we go. So it did come back up. Okay. I didn't want to push it where at least won't load LangGraph if I can avoid it. It looks like it did. All right, I'm going to kill this. Let's go ahead and push everything out here, except the test data. Made a lot of updates in here. Let's see. Exploit agent to finish workflow. God, that is so bad. Trojan, hey man, what's up? Do I know anything about IT strategy or wargaming? A little bit. I haven't done a ton of wargaming, In fact, I've done 0 of it, come to think of it. A lot of times, IT strategy depends on like where you're going with it and what you're looking at. That's a pretty broad topic. A lot of times that's where something like a security architect kind of comes in. I kind of did some of that at my last blue team role, but I didn't, it was a really messed up role, so I didn't do a ton of it. Like IT strategy consulting. There are folks I work with that do that, but that's not my area. Yeah. And so they'll go through and they'll do like war games, they'll do assessments, reading through, looking at all the different areas, that making sure that they've got certain policies in place, looking at not necessarily policies, but how would I describe what they're doing? They're going through and trying to find the holes in policies and processes that could lead to security issues. And I haven't really dug into that a ton. So my specialty is completely on the offensive side. I'll either bust in, or they'll give me access to their network, and then I will worm my way through to some objective. Yeah, I don't work directly with them. I mean, they're my coworkers, but I don't ever help them out on those kind of strategic assessments like that. All right, let's see if we can find somebody to radio to. Who's on InfoSec streams? Nobody, not even us. We're not on InfoSec streams. Nobody. That is sad. That does not spark joy. Let's see, who do we have on? Let's see, Shindigs is on. Oh, you know what? Griffin is online. We'll go right over to him. He's a great guy. All right, guys. Unfortunately, that last little bit of news was not the ending I wanted to have for tonight's stream, but it's better to know that now than later. So we're not going to make any updates surrounding it just yet, but it does answer a bunch of questions. So tomorrow night, we'll keep working on the exploitation agent and let it finish off all of its tracking and everything it needs to do, hopefully. And then we should be copacetic on it. And then we can start planning out the post-exploitation agent. Oh, yeah. I can't wait for that one. Everyone, y'all have a fantastic night. Tomorrow is Sunday. Spend it with your friends and family. Hope y'all have a fantastic Sunday. I'll catch y'all tomorrow night. Yeah. Peace out, Tigro. Yeah. I want y'all to remember one very important thing, and that is I love you. Peace. Oh, and by the way, dropped a bunch of Hack the Planets into Griffin's stream when we get over there. Deuces.